Hello. In this time, we're going to work with geometric figures, and this case are quadrilaterals, and particularly the rectangles. So let's see the properties that rectangles have. First of all, the four angles are right angles. Okay, that's the first thing. So angle A, angle B, angle C, and angle D are all right angles. Then opposite sides are parallel, and also they are congruent, parallel and congruent. So that means that AB and DC are parallel. Same with AD and BC. So the opposite sides are parallel, and at the same time they will be congruent. They measure the same, they have the same length. Okay, now we also have that opposite angles are congruent. So opposite angles are congruent. Now, consecutive angles like angle A with angle D, angle A and angle D are supplementary. All consecutive angles are supplementary. The same will happen with angle D, angle C, also angle C with angle B, and angle B with angle A. All the consecutive angles are going to be supplementary. And the last property is the one that says that diagonals bisect each other. I am doing this without a ruler, so please bear with me on that. So the diagonals bisect each other. That means that this segment will be congruent, like if the intersection point is P, DP and BP is congruent. Okay, DP and BP are congruent. Same with AP and CP will also be congruent. So basically, if we understand all those properties, in here I have this: if quadrilateral ABCD is a rectangle, then I know that ABCD, all these are consecutive vertices, so the diagonals are going to be AC. Diagonal AC will be congruent to diagonal BD. Okay, basically that's what I'm going to conclude after knowing that quadrilateral ABCD is a rectangle. Let's see the first problem that appears in your textbook. Is a rectangle park has two walking paths as shown in the figure, of course. If PS is 180 meters and PR is 200 meters, find QT. So basically what they gave me is PS, which is this side here, that is 180 meters. And also PR is 200 meters. PR is the diagonal there, that's 200 meters. So they asked me to find QT. Okay, I know that QT is just the half of the diagonal. Since we know the diagonals bisect each other, so PT and RT are congruent. The same will happen with QT and ST. Therefore, QT will be the half of the diagonal PR, which is then 100 meters. Okay, now they also ask you to evaluate this. If TS is 120, that's a different value. TS is 120, find PR. So we know that PR is the double of that segment because ST and TQ are the same or are equivalent to PR. So we know that PR will be 240 meters, which is the double of 2 and 120 meters. So that's why I'm sure that PR is 240 meters. In the second problem, they said if the measure of angle PRS, so let's see, PRS, so they refer to this angle here. If that angle is 64 degrees, find the measure of SQR. So I have SQR is this angle up here. SQR is this one. So if I consider in this figure the triangle PSR, we know that S is 90 degrees. Since this is 64, the angle on top will be the complement of 64, which is 26 degrees. The same will happen with triangle SQR. We know that the whole thing here will be 90. This will be 64, and this will be 26. Therefore, the measure of angle SQR is 26 degrees. Okay, in the next problem, now this refers to algebra, we have quadrilateral JKLM is a rectangle, and they said if the measure of angle KJL, let me see in here, KJL, so is this angle here, if that measure is 2x plus 4, okay, if that angle is 2x plus 4, and the measure of angle JLK, let's see what this one, JLK, oh, okay, is this one. If that one is 7x plus 5, find the value of x. So in the triangle JKL, we know that angle K is a 90 degrees angle. So these two are going to be complementary angles. So we know that measure of angle KJL plus the measure of angle JLK equals 90 degrees because they are complementary angles. Now we substitute for the given values, 2x plus 4 and 7x plus 5. We substitute in this equation. So I'm going to have 2x plus 4 plus 7x plus 5 equals 90. And I solve this equation. That would be 9x plus 9 equals 90. Okay, 9x equals 90 minus 9. So 9x is 81. So at the end, I have that x is 81 divided by 9, and the value of x will be 9. Okay? So after solving that, I find that the value of x is 9. Okay, now we have this application is a word problem. The problem said a community recreation center has created an outdoor dodgeball playing field. To be sure that it meets the ideal playing field requirements, they measured the sides of the field and its diagonals. If AB is 60 feet, I'm going to be placing the values here. This AB is 60 feet, BC is 30 feet, also CD, this one down here, is also 60 feet, and AD is 30. So what we know is that opposite sides are congruent. Opposite sides are congruent. And also they said AC is 67. So we have that diagonal AC. The length is 67 feet. And at the same time they said that BD is also 67 feet. So it fulfills one of the properties of rectangles that said that diagonals are congruent. Okay, since they are congruent, we are sure that quadrilateral ABCD is a rectangle because all of the properties are fulfilled in this problem. At the end, we have one problem that is or takes more time because in this case it requires you to graph some of the vertices and also figure out how to answer the questions or questions they ask. In this case, quadrilateral PQRS has vertices P negative 5 3, Q 1 negative 1, R negative 1 negative 4, and S negative 7 0. Determine whether PQRS is a rectangle by using the distance formula. So if I am going to use the distance formula, all I have to do is find the length of the opposite sides. So let me label this. Point P is negative 5 3. This is P. Point Q is 1 negative 1. So Q is down here. Then the other point is R negative 1 negative 4. This will be R, the one down here, this. And the other one is point S. So I have P, Q, R, S. What I'm going to find then is the distance from PQ and also the distance from SR. If they are the same, it means that the opposite sides are congruent. I'll do the same with SP, okay, and RQ. So I will use the distance formula. For those who forgot about that formula, the formula is the square root of x2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Okay, that is the distance when 2 points are given. So let me put also the coordinates in here, negative 5, 3, and also 1, negative 1, and R is negative 1, negative 4, and S is negative 7, 0. So if I apply the formula for PQ, then I'm going to have negative 1 minus 3 square plus, and then the other one is 1 minus negative 5, so it's 1 plus 5 square. So I did not leave enough space for that, so bear with me on this, please. So it will be the square root of negative 4 square, which is 16, and 6 squared, that is 36. At the end, that will be the square root of 52. I will leave it like that. I know it can be simplified or expressed in simplest form, but for now, I'll leave it like that. I'll do the same with SR, where S is negative 7, 0, R is negative 1, negative 4. So using the same distance formula, this will be negative 4 minus 0, so it's negative 4 squared plus, and also negative 1 minus negative 7, so it's negative 1 plus 7 squared. And this is also the square root of 16 plus 36, and at the end it gives the same as the square root of 52. Okay, so we have that PQ and SR are congruent. Now we are going to try with SP and RQ. For SP, I know that it will be the square root, and I use negative 7, 0 with negative 5, 3. Okay, so using those values, that will be 3 minus 0 squared plus negative 5 minus negative 7, which is negative 5 plus 7 squared. And that is, at the end, 9 plus 4. And it's equal to the square root of 13. So I stay there. And finally, I'm going to find the distance between points or vertices RQ. So R is negative 1, negative 4, as you see it here. And Q is 1 and negative 1. So it will be negative 1 minus negative 4, so it's negative 1 plus 4 squared, plus, and the other one is 1 minus negative 1, so it's 2 squared. From negative 1 plus 4, I have 3 squared, and 2 squared, that will be the square root of 9 plus 4. So again, I have the same square root of 13. So what I found in here is that this side, SR and PQ, are congruent because they measure the same, square root of 52 and square root of 52. And also I found that SP and RQ are also congruent. They're both square root of 13 and square root of 13. The only thing I'm missing is the length of the diagonals. Once I find that, then I'm going to be sure that this figure is a quadrilateral. So I need to apply the formula, and this time will be the distance between the vertex SQ. So that will be the square root, and I need to use the vertices S and Q. So it will be negative 1 minus 0 squared plus 1 minus negative 7, which is 1 plus 7 squared. So evaluating that in here, that will be 1 plus 64. And the answer is the square root of 65. That's diagonal SQ. Now I need to find also the diagonal PR. And the vertices for PR, if you check in there, that will be negative 4 minus 3 squared plus, and the other point is negative 1 minus negative 5. Negative 1 minus, let me see, negative 1 minus negative 5, yes, is negative 1 plus 5. So what I have is the square root of negative 7 squared plus, and this is 4 squared. So at the end, I have 49 plus 16, and the answer for that is 65 also. With this, I'm pretty sure that the figure is a rectangle, since the opposite sides are congruent, the pair of opposite sides are congruent, and the diagonals measure the same.